One. All right, so yes, this meeting is being recorded. This is the webinar for the Trees Around the Globe Student Research Campaign. And we're going to be talking today about Trees Around Greenbelt, Maryland, exploring past and present imagery with Dr. Christopher Shuman from the University of Maryland, Baltimore County at the NASA Goddard Space Flight Center. And we're going to talk a little bit about some of the logistical campaign things to start, and then we will get right into Dr. Shuman's presentation, feature presentation. Now, once again, if you could put in the chat where you're from, that would be great. And also, if you have any questions that come up during the webinar, during my introductory slides, and or Dr. Shuman's presentation, please put those in the chat box and we will answer them following the presentation. So, a couple things here I want to go over before we go any further. I always put up our campaign team. My name's Brian Campbell, and I'm at the NASA Wildlife Flight Facility in Virginia. We have Dorian Janney. She's at NASA Goddard with ADNET in Maryland, Greenbelt, Maryland. Peder Nelson at Oregon State University. Peder is a researcher at Oregon State University and professor. Dr. Christopher Shuman at NASA Goddard Space Flight Center and University of Maryland, Baltimore County in Maryland, and Peter Falcon at the NASA Jet Propulsion Laboratory in Pasadena, California. All right, so some of the metrics since the campaign began September 15th, 2018, we have 12,857 tree height measurements from students and citizen scientists at 6,657 global sites. So that's really awesome stuff. So there's an amazing amount of data out there for you to look at, for you to develop research projects and just, investigate. We also have 9,880 land cover measurements from 6,742 global sites and 8,639 green up, green down measurements, also greenings. These are from students from 432 global sites. And a couple other things here you can just see. We've had 17 webinars. We have 20 blogs, and we have 100 uploaded documents. So these are all really good resources for you to use, when learning about the campaign, developing student research projects, and learning all about trees. Last month, we had our latest IOP intensive observation period, and that was January 2020, and that was all about land cover. We had 400 land cover measurements coming in from 229 locations in 10 countries around the world. And you can see highlighted here in red, these are the countries that participated. These are campaign participants. Now, these aren't all the participants. There are some people in land cover that have submitted it through citizen science. And those of you who are part of the citizen science program as well, and you're doing land cover observations, you're included in this. But there's also citizen scientists using the NASA Globe Observer app using the land cover tool that are not included in this because these are all the people that are coming in from the campaign. So our winner here was O. Gupta from Globe in the United States, and he submitted 101 measurements for land cover. So a quarter of the land cover measurements coming in from campaign participants came in from this gentleman from the United States. So, congratulations to him. And anybody who participated in this who is part of the campaign, if you go to your Globe profile page, you will see either a digital badge from like on the top left if you're a participant for land cover, and if you happen to be a winner, either this one or the past two ones for land cover, you will see the winner digital badge on your profile page. So pretty cool stuff. I want to remind you the International Virtual Student Symposia, the IVSS, the due date is coming up very quickly. It's March 10th of 2020. If you want to submit a research project related to the tree campaign, or if you're doing other projects as well in your classrooms, this needs to be submitted by March 10th. And you can go, learn more I have a bit.ly link on the bottom here that you can take a look at and learn a little bit more about what's going on and, what kind of the checklist that you need to do in order to submit this student report to the International Virtual Student Symposia. So we have students submitting from many countries. I forget what it was last year, but it was well over 30 countries, I believe. It could have been around 50 countries. I'm not sure the exact number, but ones coming in from all over the world. I always bring these up after I remind you of the IBSS is, you know, on our website, on the campaign website, we have potential research questions. And these are ones that were primarily brought up during the Trees Campaign open forums back in December. So we have lots of questions here. These questions were brought forth by participants in these two webinars, the informal webinars that we have. So students and educators alike came up with some of these. These are examples of questions that you could possibly develop a research project on. I won't keep them all up here for long, but if you go to the website, go to the Globe Campaign website for our Trees Around the Globe Student Research Campaign, you can look at all these questions and maybe you have other ones, you know, that you had in mind. So, you know, sky's the limit with this research. So, and also I should mention, if you do a project, you submit a project to IBSS and it has in relation to this campaign, please mention the campaign in your, you know, either your poster presentation or your report that you submit to the IBSS. That would be great. Thank you. Now, I'm going to do a little call out for student presenters. We're looking for students who have been doing any research in tree height or land cover or greenings to present, do short presentations, you know, 15, 20, 25 minutes during April and May of this year for this campaign. So basically what we're doing now on the webinar, you'd be part of it giving a presentation. If you go back to the archived webinars from the first year of the campaign, you can see that we had students from several countries presenting, everywhere from Croatia to Switzerland to the United States. So we had lots of presentations by students doing research. Now, you don't have to have a fully blown, you know, a full research project complete in order to present. What we want you to do is to show us how you're doing the observations, how you're doing the measurements, what you've determined, potentially what your research question is, and how you're doing this. So, you know, we have lots of them from all over the world doing these presentations. So, you know, we'd really like you. If you'd like to do it, please contact me. My email's on the bottom, brian.a.campbell@nasa.gov. And remember, this is for April and May. So if you'd like to do it either one of those months, please let me know. And, you know, we don't want to make any extra work for you. We just think that it would be great because people love when they get to see the students present, because it's really showing just how important these local measurements are to the students. So, you know, we know it's important to the science world, but to the students and in the classroom, we really like to see the presentations because we know it's really important in their hearts to actually do this research to help us understand local environment, which have global impacts. I want to bring this up again. I brought this up at the last webinar. The entire month of April of this year, we will be having a Trees Challenge 2020, Make Every Tree Count. This is for the NASA Globe Observer. So it's celebrating the 50th anniversary of Earth Day and also the 25th anniversary of Globe. So this is with the Globe Observer. So this is using the Trees tool on the NASA Globe Observer app. And this is a free app. For those of you who don't know, it's a free app. Just go to NASA Globe Observer in Google Play or in the App Store and just type in NASA Globe Observer and you can download it and get started right away. But for April of this year, we are going to be doing the Trees Challenge 2020. So we're trying to get as many tree observations as we can with folks using this app. So we're super excited about the citizen scientists doing this. Now, with that said, during the same time, we will be paralleling this with the intensive observation period for tree height, the entire month of April 2020. Now, what I'd really love to see is that someone from this campaign would also, who would win this tree height intensive observation period, would also win the Trees 2020 Challenge, Make Every Tree Count. That would be absolutely amazing if someone from the campaign would actually, would also, I know you can do it, would also win, you know, top honors for the Trees Challenge 2020, Make Every Tree Count. That would be absolutely amazing. You can go to this website. You can just go to the campaign website for this to learn more about the IOP as well. You can click on, you know, you can go and check out that link. And when you go to the campaign website, click on intensive observation periods, and you can see this. So if any questions, please put those in the chat box. That would be great. I'm not looking at the chat box right now, but I will in a couple minutes. Okay, so next month, we have a campaign webinar, and this is going to go a little bit into the science of how we derive tree heights and other structural vegetation characteristics. So they're going to, the presenter, Dr. Latha Bhaskaran, out of the NASA Jet Propulsion Laboratory, will show you how scientists map habitats in a post-fire environment. So they're using LiDAR, okay? Like, ISAT-2 uses lasers like that, okay? Going to be using LiDAR to help derive tree heights and other structural vegetation characteristics. But they're going to be focusing on how this is done, how these habitats in these forests, how they're mapped basically after a fire, after a massive fire. So this is going to be a really cool presentation. We're really excited about this. So, come check this out. It is on Tuesday, March 17th at 2 p.m. Eastern Standard Time or 6 p.m. UTC. That might actually be 2 p.m. Eastern Daylight Time. I think that changes before that. I'm pretty sure. I'll check that in. So, with all that said, today's feature presentation is Dr. Christopher Shuman, and I had to use that picture, Dr. Shuman, because I love that picture. I've loved that for a long time. That's awesome. So he can say anything he wants about that picture. That's fine if he'd like to. But we're going to be talking today, what Dr. Christopher Shuman is going to be talking about today, and I hope you have lots of great questions. He's going to be taking you basically on a tour of trees around Greenbelt, Maryland, in the United States. It's just outside of Washington, D.C. It's just basically to the, the northeast of Washington, D.C., and it's exploring past and present imagery. So this should give you an idea of, some of the things that you can look at when you're doing your research as well. So I will pass it over to Dr. Shuman, and I will stop sharing when then he can go ahead and share.
Thanks, Brian. Let me get these boxes out of the way here. Okay. Okay. Share screen. I guess I shouldn't have so many windows open.
It happens.
There we go. It changed positions on me.
Uh-huh. All right, looking good.
Okay.
All
right, can you all see that?
Yep, looks good on our end, or at least my end.
Okay, great. So this idea got started last year when NASA celebrated its 60th anniversary. And so what I'm going to do is take you through time a little bit and show you my town over here, Greenbelt, Maryland, which is right next to Goddard Space Flight Center over here. And because we have imagery that goes back just to the time that Goddard was first being built, we will show you how this large research center has kind of evolved over time using a number of images that were available and could be incorporated into this short talk. So I live in Greenbelt. So I live over here in a small place, and I drive every day over here, every work day over here to building 33. This image is a little out of date. That building is almost already ready to be occupied. I think it's building 37. And you can see kind of the main campus of Goddard. This is called West Campus. Over here is East Campus. There used to be a road that ran right through campus. And that has now been blocked by some new buildings. But what we are able to show over here is sort of changes to the tree cover, both broadly through this area of Maryland that I'm familiar with, but also with some details in particular parts of the Greenbelt, Maryland area. Okay, so that gets you situated here. As Brian said, just outside the Capitol Beltway, that's the big road over here. And Greenbelt is separated from Goddard by the BW Parkway, the Baltimore-Washington Parkway. So you'll see those features again. All right. This is something that I'm sure you're all pretty familiar with. I won't read them all to you, but it struck me today as I was just getting ready to go to work that I was taking a banana from a tree into work and an apple from a different kind of tree into work. And that's not even including the wood that I worked with over the weekend, doing a project down at my daughter's house down in Richmond, Virginia. So, you know, there's just no doubt how important trees are. And that's one of the reasons that you're all here listening and exploring the Globe Observer tree tool, hopefully during the intensive observation period and supporting Make Every Tree Count later on in the spring here. So some of the questions that Brian was showing a little bit earlier during his presentation touch on this. Certainly trees are under threat from a number of factors around the world. California and Australia's recent wildfires are just one type. Drought and blight are definitely a problem. And as we'll see here at Goddard, because this center is getting into its 61st year, basically, of existence, that some trees are simply aging out. And we'll have some illustration of that later on in the slide set. So awareness of these issues is just one reason to monitor and support trees and other woody plants, because not everywhere grows trees. And in particular, you know, it's a function of your ecosystem, what kind of plants you'll be able to contribute to the trees program. Okay, so as I said, this was begun in part because NASA was celebrating its 60th anniversary. And so I went to the USGS's online archive of aerial photographs and discovered that over here, the first 3 buildings of NASA Goddard Space Flight Center were visible in February of 1960. You'll still see the lake here we call Greenbelt Lake, and over here is a lake out on the Beltsville Agricultural Research Center, land from which was given to Goddard so that it could be founded. You will also see the BW Parkway is still in existence, but there's no sign of the Capitol Beltway. So that's all to come. So just keep those first images I showed you from a recent satellite acquisition in mind as we go forward in time here. So 1960, farm fields out here in Bark, Beltsville Agricultural Research Center, and the first perimeter fence for NASA Goddard Space Flight Center is sort of visible. But a whole lot of trees out here are where Goddard expands into. And we'll see that in the next slide. One of the challenges of using aerial photographs, however, is kind of visible in that turn, in that because these are being acquired at 10,000, 12,000 feet above the ground, they're subject to some interesting winds that can sometimes make lining up individual aerial photographs kind of challenging. Again, you can still see the Bark Lake out here, Greenbelt Lake out here, the BW Parkway, and the beginnings of what will be the Capitol Beltway, that major ring highway around Washington, D.C. And for those of you at Largo, you may know where the location of Eleanor Roosevelt High School is in Greenbelt. And you can quite clearly see in 1963 that Eleanor Roosevelt doesn't exist yet. Greenbelt Road has changed dramatically as Goddard has gotten bigger. There's now about a dozen buildings on center. The West Campus is beginning to look much more like the West Campus that we saw in those first couple of slides. The perimeter fence has expanded out around a much larger area. And East Campus still doesn't really exist. But West Campus, some of those buildings, spacecraft assembly building over here, they're definitely beginning to look like the campus you would see if you visited today. And then we jump forward a little further in time to 1977. Eleanor Roosevelt now has its football field and track. The Capitol Beltway is clearly visible, connecting to the BW Parkway. Lots of houses have been built out here in the periphery of what was the old part, the original part of Greenbelt, Maryland. And Goddard's buildings have continued to expand. In part, we had to actually put a lake in to help control stormwater runoff because there was so much more paved and hardened surfaces, roofs and whatnot, parking lots. So Goddard's actually built a lake out here. That island is still visible. And so what I'm trying to show you is that as towns and communities develop, Eleanor Roosevelt, a lot of trees got taken down. As Goddard expanded, a lot more trees got taken down. Bark remains pretty much the same. The old part of Greenbelt, not much different, but there have been definite expansion of human structures with the peripheral loss of trees that once provided oxygen, shelter, and all the things that we appreciate trees for. Now, the good news is that technology, nothing wrong with these very highly resolved black and white aerial photographs. They were chosen to be black and white because black and white film had the finest grain or resolution for those years. But as we go forward in time, technology advances, and the Landsat satellite actually got launched. First one in 1972. We'll be celebrating the 50th anniversary of what became known as Landsat 1 in 2022. Landsat 1 carried the multispectral scanner, and you can see very little of Greenbelt in any kind of detail with its resampled 60 meter pixels. Even with the first thematic mapper on Landsat 4, about 10 years later, these 30 meter resolution pixels only hint at, shall we say, Eleanor Roosevelt, Goddard Space Flight Center itself, the town of Greenbelt. You can make out the lake there and the Bark Lake over here. You can make out the BW Parkway, the Capitol Beltway, but very faintly. But some of these data were the first to get the high resolution, like continent-wide mapping of vegetation. So assembling all these images was definitely one of the first steps to getting some of the good maps we now rely on to see change over time. Somebody can mute. Thank you. And at the same time, aerial photographs are evolving. So in 2006, the state of Maryland actually not only acquired these high resolution aerial photographs, but the USGS orthorectified them and geolocated them so that I could make a seamless map that looks very much like that first image I showed you of the high-res satellite imagery in Google Earth Pro. This data is available at the USGS's online archive. And especially for Largo, it might be fun to see how much imagery is available showing the same kind of evolution of Largo High School and surrounding area as I was able to do here for Eleanor Roosevelt. Eleanor Roosevelt has expanded. That's one of the things that tells you that all these apartment buildings along the BW Parkway are contributing students to the local school system. So even over here, the east campus of Goddard, including building 33, where I'm sitting right now, is now visible. But you can see that there's many fewer trees, especially on East Campus and in other areas of Greenbelt around this shopping center, for example, and apartment buildings and professional buildings south of Greenbelt Road. So all of those images were more or less showing exactly the same area over time. And it gets even more exciting as technology advances. This is a currently operating 10-meter multispectral satellite sensor called Sentinel-2. There's two of them, 2A and 2B. And boy, compare that to the thematic mapper image from 1982. There's a whole lot more detail. You can actually see some areas where people are growing trees specifically to basically understand how they're growing out by bark. So this kind of gets even better. This is a 2019 image, and what I've done is I've merged a high resolution satellite image, Worldview 2, from roughly the same time frame. Think about it. From space, we're now acquiring multispectral images with less than 2-meter pixels. The panchromatic imagery is about 3 times as good. One of the reasons that I'm showing you this is that NSF and NASA-sponsored researchers have access from the National Geospatial Agency to this kind of data. And some of the colleagues that I work with down the hall are actually using Worldview 3 and Worldview 4 imagery to count trees across large portions of Africa. You can not only see them as individual trees, especially in the drier portions of the area, the drier portions of Africa, but if there is a stereo image, you can actually get a tree height estimate from the digital elevation model that the stereo images allow you to produce. So over on the left side is that 10-meter Sentinel 2 image. We're rebuilding Greenbelt Lake Dam over here. That's why it's all brown, and the lake is now has most of the water out of it. And that activity is ongoing. But the lake at Goddard is still quite clear. That island is even casting a little bit of a shadow from the trees that are on it. And it was a bit of a drought, a flash drought, and we'll come back to that when this image was acquired, late summer into the fall. And so the bark lake has actually got a whole bunch of organic matter on top of it. And that had some impacts on the trees, the flash drought that happened at the end of last year. Okay, so just to illustrate why we're going to be focusing on some of the trees at Goddard during the April challenge month, but they're aging out. This is this tree over here. Both of these are near building 12. You can kind of see from the lines that roughly where they were on Sunday when I took these pictures. This tree has had a combination of probably insect damage as well as storm damage, but is clearly in a very weakened position. This tree was fully leafed as I walked under it in September. And then abruptly, somewhere around the end of September, all the leaves went brown and it just stopped living. That is probably an impact from the flash drought. And so those are just illustrations of the kinds of trees that we hope will get taken down and replaced, and new trees put up to absorb carbon and basically make Goddard's campus a little greener in the years to come. But it's a problem pretty much across the older portions of the campus. And also in some of the new portions of the campus, trees that were designed to be planted as landscaping, many of those have not done well and need to be replaced. I also point out the NASA Goddard Visitor Center right here. Some of you may have visited it, as well as the Delta I rocket that stands behind it. And I do that because in the next slide, you will see the Delta I over here behind the Visitor Center, but also these trees with a hint of red that have already budded out in this unusual winter. So not all the trees are in dire straits at Goddard. I wanted to end the detailed look at trees at Goddard with kind of an upbeat message. But like a number of the trees, some of the infrastructure at Goddard, this is building 17, it has kind of not weathered well. And so building 17 itself is being reconstructed right now. And if you haven't visited the visitor center and you're local, please think about it. There's some amazing stuff there, and we hold events up at the visitor center. So look out for opportunities to come check that out. One of the reasons I wanted to show the Delta One is because a Delta Two, such as the one you're looking at, launched a satellite that I worked on back in January of 2003 called ISAT, the Ice, Cloud, and Land Elevation Satellite. ISAT-2, I'm making a little joke with the header here. ISAT-2 launched in September of 2018 and is going well on its way to taking far, far more data with its much more advanced Atlas instrument than the original ISAT mission did with its geoscience laser altimeter system. But both are laser altimeters, and we're going to take a quick look at some of that data from ISAT-2 that's helping us measure trees. So there's this really cool tool that you have access to if you have the opportunity to be viewing this presentation, for example, called openaltimetry.org. OpenAltimetry is a repository evolving over time, taking in ISAT-2 data and making it readily accessible to you. I'm showing you a profile near Greenbelt, actually the closest one in OpenAltimetry. There will be more. You will see Greenbelt Lake in more detail than you did in the previous images, but some of the same features are very present here. This is part of my town over here. And right across the base of the dam, an altimetry profile was acquired on April 5th. And the ATL-03, the photon data, looks like this. This is actually really pretty cool because knowing the area, I was able to basically look at this and go, that's the Capitol Cadillac car lot. There's a tree buffer between it and the Capitol Beltway, as you might expect. Not everybody wants to listen to traffic, truck traffic in particular, going by. And you can actually see that the two sides, the inner loop on this side is slightly higher than the outer loop of the Capitol Beltway on this side. Then there's more trees as the profile crosses down this hill. The trees are quite high on this slope leading down to the stream that flows out of the Greenbelt Lake and then up the Greenbelt Lake embankment to more woods behind the City of Greenbelt's Public Works Department. Crescent Road, one of the first roads in Old Greenbelt, is visible here as this relatively lower and open area where the basically not too overhung with trees. And then the profile passes near Greenbelt Police Station and the animal shelter off into more woods and an apartment building. This is the kind of data that you can get access to for your area of interest simply by going through to the OpenAltimetry site and exploring that. And the ATL-08 product is the one that is also readily available here. But what it does is it resamples these individual photons that are returned to the Atlas instrument as 100-meter segments and derives an estimate of the tree height and also the ground surface below. I think the ATL-03 data is a little more instructive as to what the landscape looks like along these laser altimetry profiles. But you can explore it and tell us what you think in one of your projects maybe. So here is kind of where that altimetry profile was acquired. There's the embankment before it got dug up. And you can see the ground slopes up from the stream that flows out through the dam over there at the left edge of the image. and then up the hill behind Public Works, where for some reason they have a large pile of discarded telephone poles. Not everything in your city government will make sense to you. That's just one of the things I've learned over the years. But this is all exactly where you can come and actually get some tree measurements, which Kristen Weaver and Heather Mortimer did in actually in December of 2019. That's a typo, sorry about that. And all of these are globe trees measurements that you can basically get a look at. Heights are a range from 10 to 30 meters, which I think matches fairly well to the range of heights that you might see through this area. So it's pretty cool. Not only do you get to see trees from the ground, but you can also see trees from space. So wrapping up, measuring trees with the Globe Observer Trees tool and measurement protocol is just one way to monitor your local environment. The different types of remote sensing data that I was kind of introducing you to are another way you can keep track of your local ecosystem and its changes over time. It's really kind of fun to check out the ISAT-2 data. So I hope you will, and you can find some near where you live. We will be focusing on the trees across Goddard during the April challenge because it's kind of important for us to be aware that they're becoming hazardous and maybe should be taken down and replaced. We will also be trying to get the higher resolution Worldview 3 stereo coverage to help us do that. That'll be really cool if we can get that high resolution satellite imagery. So just to emphasize what Brian was saying, make every tree count, support the Globe Observer application, and find ways to check out your environment and document what you find. So I'll end with this, again, kind of upbeat note. This is probably the oldest tree in Maryland. My daughters and I traveled to it last fall. It fortunately survived the flash drought. The plaque that my daughter Nicole is leaning on is kind of visible at the lower left. But basically, they believe this tree existed before the United States Constitution was adopted, and is still, as you can tell, quite green, quite beautiful, quite amazing. And so check it out at the link at the bottom there, Travela Oak. Travela is the location, and this ginormous oak is just a really cool thing to stand under and just marvel at what it must have seen pass by on the road over the many, many decades it's been alive. And with that, I will take any questions.
All right, thank you so much, Dr. Shuman. Is anybody who have any questions? I don't see any in the chat right now, but feel free to unmute yourself and ask a question if you would like, and we'll pause for a second while you do that.
Anybody know about the Travela Oak before I showed that to them? Some of you are local, so I was just wondering if anybody else had already been there.
Hey, Chris, I had the opportunity to go on a champion tree hike, and we went around and saw, I guess, about 6 different champion trees of different species that were in Maryland, many of which were along the C&O Canal. I have not seen the Travela Oak, but I will have to go and check that one out. But I could get, for us, the information on the champion trees. Actually, I'll go and try to do that now and put that up there, at least for the state of Maryland.
That would be cool. Thanks.
Excellent. Anyone else?
Brian, you have a view out your window of the Wallops runway area.
I do, with lots of trees over on the other side of Chincoteague Road.
Yeah.
Yeah.
Well, we've talked about acquiring more aerial photographs and seeing how Wallops has changed over time.
Yeah.
We should continue that discussion.
Yes, definitely.
Did you
Right. You
mention,
must.
I'm sorry, this is Andy Henry. I may have missed it, but did you mention the resolution of the ISAT2 image data point?
The ISAT profile is essentially overlapping footprints of laser energy, only some of which get photons back up to the telescope on the Atlas instrument. So basically, the lasers on Atlas, on ISAT2, are firing at 10,000 times per second. And that energy spreads out into roughly sort of a, call it 10 to 15 meter cone, depending on the type of topography it's crossing over. Those photons hit the surface and some of them make it back. So effectively, the profile on a clear day with a fairly distinct surface below it will probably have overlapping footprints, overlapping photons effectively. But if it's at all cloudy, you'll get many of those photons will get absorbed, they'll get delayed, scattered essentially. And of course, the tree surface itself doesn't make for a perfect reflecting target. So there are some discontinuities in that ATL03 profile, but it is a pretty good illustration, especially where you have dense canopy and distinct land surfaces of the kind of essentially continuous, almost continuous profile that you can get from ISAT2 Atlas data.
The vertical accuracy of that is, what's the sort of error band of that, or the range?
There are a couple of ways of assessing that, and I don't know exactly what that would be for a tree cover at this point. In other words, it's kind of hard to assess the accuracy, but they are talking sub-meter levels for some of the more reflective targets, centimeters essentially.
Thank you.
All right, great question, Andy. Anybody else? Oh, all right. Here's a question from International, the school in Largo. How do you know about how many years old a tree is? So,
well, for the case of the Travela oak, and Dorian, I'll have to check with you how to pronounce the name of that little town. There are records basically that, because families used to live on a farm, for generations, there would be documentation of it in the family records. Scientifically speaking, one of the ways you can do it is you take a very specialized drill bit and you drill a very small diameter core into the tree trunk, and you count the annual layers of growth that you can retrieve from that tree core. That's one of the ways that you can actually determine pretty darn accurately how old a tree might be, especially one of those champion trees that Dorian was mentioning.
excellent. Anybody else? Great questions.
Brian, there was a question about the ages for the trees challenge. I can answer that one. Oh, I guess I can turn on my video. So I'm not officially part of this, but I'm the deputy coordinator for the Globe Observer project. So for the trees challenge, the Globe Observer app is designed for ages 13 and up with their own account, but younger students could absolutely do it using a parent's account or with adult supervision. And using, a parent's email to register. So I think, basically what you're doing with the phone is just kind of tilting it. So younger kids would definitely need some guidance and some help with that. But the app by itself being used alone is 13 and up. But younger with supervision.
Thank you, Kristen. And Bo, just so you know, that's for April 2020 for that entire month. So, yep. All right. Anybody else have any questions? All right, with that, in the time remaining, I'm going to pass the reins over to Peder Nelson. And, oh, is there another question there? Sorry, no, it was a link. I'm going to pass it over to Peder Nelson, and he's going to discuss a little bit, about with you, a little bit about some of the things that he was throwing in the chat during Christopher's presentation. Looking at some of the snow-covered conifer trees that they got in Oregon, and as well as some other things. So let me pass it over to you, Peder.
All right, well, thank you, Brian, and thank you, Dr. Shuman. That was a really good overview of how we're actually using satellite imagery and this aerial view to track trees over time. And what I wanted to point out is that you don't have to be an expert like Dr. Shuman to actually start looking at changes over time. There are a couple tools out there that have facilitated this, made it a little bit easier. And so, as was pointed out, there are certain scales, what we can actually see, and that we want to keep in mind. And sometimes it's important to recognize that technology changes, but there's ways that we can actually use some of that 1984 sort of blurry images to actually understand an area. And so one of the longest running satellite projects is the Landsat mission. And so that really does give us this 1984 to 2018 view. And so in the chat, I dropped in a link to one of the tools that Google has put together, which allows you to go to a location and time travel. So here we are looking at the Goddard Space Flight Center visitor campus that we were looking at earlier. We can see the white tops of those buildings that were created. And so that's obviously very different than the brown that we see of the dirt and the construction, right? And so that's what it looked like in 1984. In particular, I want you to see some of these, the tree cuts that Dr. Shuman also pointed out. So the nice thing is you can zoom to any location on Earth, but here, if I actually just play through, we start to see an animation of annual changes over time. And obviously, many of us were very young when these things were happening, but we can see the buildings, we can see these sort of changes over time. And importantly, being able to compare this 2018 to 1984 allows us to really get those differences, right? And so, we can't count the individual trees here, but we can see the places that we want to go measure, right? And so just doing this comparison can really help you to localize what's happening in your local area so that when you do go out and make tree height measurements, you have a sense for the age of those trees. Because you can use a tool like this to actually time travel, go back and forth. And it's just amazing the patterns of houses and why did they build the houses in some of these weird shapes that they did, right? Great sort of questions to investigate compared to some of these big tracts of intact trees, right? So this is where these on the ground photos really can help us, us as scientists, but also you to understand this aerial perspective, because it's very different when you go to the ground, go to these locations, like what Dr. Shuman was showing. What do those trees really look like? So I want to encourage you to go and explore this tool, because the nice thing is you can actually share this with other people. You can share the direct link, like what I did in the chat window, directly to this location. Or if you have a web page or a blog, you can actually embed this view into your web page so that other people can see this and see what's happening in your local area. And then give us some context. How big are these trees? What type of trees are they? Do they lose leaves at any time of the year? Or do they stay green throughout the whole entire year? Because importantly, we don't know what date, what month this was actually taken, right? Google's not sharing that. They're just saying that this is what it looked like in this year. So that date can really tell us whether Google did this right and they're actually showing us what the ground conditions look like. It's green or not green, right? So there's a lot of, I have a lot of fun with this tool because you can go anywhere in the world and explore and do a comparison to maybe another globe school or some of the other research that's out there. So this is a really fun and exciting tool, and I've shown you over the last couple of Trees Around the Globe campaign webinars, a couple of these tools that allow you to time travel. So this Google one is actually pulling data from NASA and the US Geological Survey, who managed the Landsat mission. So, so hopefully they'll add to this and we'll get a 2019. But that's a fun one to explore. But I also want to highlight, because it is helpful to get onto the ground and actually see what it actually looks like. So if you're not aware, Google has added basically they're taking Google Earth Pro, which is on desktop, which is what Dr. Shuman was using to view his data. Now in Chrome, in the Google Chrome browser, they have the same Earth data, and you can actually go to places and explore this in 3 dimensions. So I want to highlight this because here's the Goddard Space Flight Center Visitor Center. And so here you can actually see kind of how big these trees are in this location. Importantly, you know, you can actually see the rocket that they have out there. I was really excited to see this cell tower that is closely associated there. And so this is actually a really neat way that you can get in and start to kind of get that 3-dimensionality, similar to if you actually went on the ground. But I want to highlight that the data is not complete.
Yes.
Here we are, you know, only half of the buildings or trees at that location have this 3-dimensional height to it. So this is the ongoing science that we're doing, but it's really exciting because you can actually zoom in and navigate around just like you are in Google Earth, and you can spin around. And what I want to highlight is you can get a profile similar to what Dr. Shuman was saying of those heights of trees. So again, it gives you a way of connecting what you're doing out on the ground to some of these neat visualizations, because you see how tall this cell tower is over those trees, right? They're almost twice as high as those trees. So that just gives us some interesting things to go explore. And as I go through, we can actually start to get a sense for an intact canopy and some of the data that Dr. Shuman was showing us. And then importantly, you know, here we are, we actually drop down, and the roads that he was showing us earlier become very obvious. The size of the buildings in relation to the trees. So this is where we're going. And over the next several years, you would expect to start to see, not just seeing things from the way, you know, the way that we've been looking at it, straight down without that structure that we're used to seeing, to now all of a sudden having this 3-dimensional way of looking at our landscapes. So to me, this is really exciting, and the activities you guys are all doing helps us to understand this, and you can use these tools yourself. So with that, I wanted to show you those kind of exciting things, and so go out and record some of these observations and do some of these measurements so that we can track these changes that are happening out there.
That's
Yes,
great, Peter.
Yep, take those measurements. You know, start taking them now if you haven't already. Continue taking them if you have already started, and then definitely in April, you know, take as many as you can. So this is going to be amazing stuff. So excellent. So this could be, here's a little question for you in the chat, Dr. Shuman. It says, how do trees affect the weather? It's a loaded question right there, but.
Actually, Jim Tucker gave an interesting talk in H114, the big conference room down here not too long ago. And one of the things he mentioned was that the work that he has done over many decades of research has been to illustrate the importance of understanding the vegetation cover as it takes in and gives off moisture. And so, not sure that I can speak to how trees affect the weather, but they certainly help cool the surface. They certainly take in moisture, absorb it, and release it as they essentially live and breathe. And that helps basically moderate the weather systems as they come and go. And so for one of the things that Compton, Jim Tucker mentioned was that when they tried to model the atmosphere with a static ecosystem, the model didn't work well. They had to put a dynamic ecosystem in order to get the climate model results to work better. So the trees are definitely part of the system that we're all living in and are an important part of that system.
Excellent. Yeah, great response for that. Yeah. Have one more question here, and it's kind of a, says, were you able to gauge the impact of deforestation, the extent of its impact to a certain demography? Just trying to figure out the actual context of the question.
I can hop on that one, Brian.
Okay, thanks, Peter.
Because this connection of land cover change, in this case, tree cover, and who's living in that location is a really big question. And so one of the pieces is that we first have to do is just map out where things are changing, and that's just the first thing that we need to do. And once we've identified where things are changing, then we can start asking questions about how that affects the people living in that area. And so one of the layers that NASA has produced is population estimates for particular areas. And so you can use those estimates of who's living or the number of people living in an area, overlay that with these places that we're seeing changes, and help to sort of understand who's being impacted, maybe some of the decisions that go to why things are happening in particular areas. But first, it all goes back to that map of just where are things changing before we can really get into some of the questions about the impacts of those, and in particular, future scenarios. You know, thinking about climate change, thinking about you know, that interaction between surface temperature and our trees, right? And so it is a really big concern about where changes are happening, where deforestation might be happening, and who is impacted by these events that are out there.
One of the many articles that I've read recently, and it's actually quite a quite accessible topic, is people reforesting areas, in part because of the need to absorb some of the excess carbon in the atmosphere. But coal mining areas in Kentucky are actually trying to revegetate some of the areas that have been strip mined in order to make their local environment more livable, essentially stabilizing the landscape and trying to bring back a more sustainable type of economy that isn't so destructive to the landscapes. So that's just one of the many stories that you'll find where people are going, we should be planting more trees. A little farther afield, a colleague of mine who works at the Danish Geological Survey, well, it's GEUS, I can't actually pronounce how they say it, but is planting 5,000 trees in southern Greenland because of the close association between Denmark and Greenland. And when you think about how challenging it is to keep trees alive even here in Maryland, you can well imagine the challenges of trying to grow a forest in Greenland, even southern Greenland. And one of the little side stories I can contribute is when US Army personnel were stationed on the west coast of Greenland at a place called Sandøy-Stormfjord, there was an Air Force base there, and they went outside the Air Force base and they planted trees up the fjord away from where they were living. And so because of the very short growing season there, those trees are literally a few feet high, but they are species that you'd be familiar with because, like us living here in Maryland, people took what they knew and took it to Greenland with them. And so it's just kind of a, you know, you're walking along the outwash plain coming down from the glacier coming off the side of the Greenland ice sheet, and you go, oh my God, that is a tiny little oak tree. It's amazing when you see them.
Hey, Chris, I just put something in the, a link in the chat window. Yesterday, I received 5 trees for free from something called Tree Montgomery, and all of them, because I used my, my Globe Tree Observer tool, all of them are over 20 feet already. Really nice trees, and they're all shade trees, and they are to, you know, improve the tree canopy here in Montgomery County. So I put the link up there, and people, if they're interested and have room, my home was built on a former farm. And so there were no trees in the area. And so many of the neighbors are you know, trying to increase the tree canopy. So I thought that was a really nice idea to have those. And thank you so much. I have to run for another meeting, but this was really, really interesting. Thank you.
You're very welcome.
Excellent. Thank you, Dr. Shuman. Thank you, Peder Nelson, for the discussions today. I think this turned out really well. And once again, this is recorded. So if you want to watch this again, please do. It'll be on the webinar page for the campaign tomorrow. And please tell your colleagues and your students about it to take a look at it. And get those tree height measurements in, get the land cover observations in, measurements, get the greetings in. So, you know, once again, thank you. And I'm going to stop recording right now.
Thank you.